Do you know centroid and second moment of area are the key properties in designing any structural or mechanical system? In this lecture, I will solve practical examples related to finding centroid and second moment of area. Hey friends, if you're new here, I am Dr. Jawed Qureshi, a senior lecturer at a London university. On this channel, we explore technical and human skills to help us lead more productive, happy, and examine life. In this lecture, I will be solving two worked examples related to centroid and second moment of area of different cross sections. These are the two examples that I will be solving. First is a T section, and second is a section which combines triangles and rectangles. Let us now solve first example, which is a T compound section.
Today's topic is about working out centroid. I want to start with a very simple question. Why do we study centroids? What's the need?
So you can find out the second moment area.
Yes. To work out second moment of area, if we don't have centroids, then we won't be able to work out second moment of area. And why second moment of area is important? Because we will always use it to work out deflections in beams. So the deeper the beams are, the less deflection they will have. So that is the reason you would have seen that beams are always deeper. Their depth is more than their width. When we talk about columns, columns are vertical members. In columns, you would have seen that their width, their depth are nearly the same. But in case of beams, we prefer deeper beams because for deeper beams, we have more second moment of area, and the depth has a cube in the formula and width does not have any power. So from our discussion up to now is that we need to find out centroid. If the shape is symmetrical, then centroid is simply at half of the shape. But if the shape is not symmetrical, then we will have to use some formula to work out centroid. And we need centroid because we want to work out second moment of area. We need centroid because gravity acts at centroid as well. So consider this compound section in this figure. Calculate the position of the centroid X bar and Y bar for this compound section. The section is a T section. And in this T section, you can see that you have got upper flange and you have got this web. So it's a T section, 100 by 50, the top area. The web dimensions are 200 by 50. One thing to observe here is that this section is symmetrical with respect to vertical axis, but this is not symmetrical with respect to horizontal axis. If I pass one line, the section is symmetrical with respect to y. It is not symmetrical with respect to x. If I take a mirror line with respect to y, the section is essentially the same. This is a kind of compound section, and I can work out the position of centroid. So the first thing first is to draw origin point. And then you have this x-axis. You can take this origin at any point, but I would prefer to take it as extreme left point of the section where x and y. I would take horizontal axis as horizontal datum axis as the bottom point, and I would take vertical datum axis as extreme left point. So wherever these two axes meet, I call it as origin. First, you have to locate origin. In that way, you will be able to find out centroid. And then I would divide this into two areas. So my first area is the top one, where I have this is 50 and this distance is 100. This distance here is 50. The vertical distance from here to here is 200. All dimensions are in millimeter. The first thing is to divide this into two areas. So first area is the top one. The first area is this 100 by 50. So I can say that A1 is equal to 100 into 50, 5000 millimeter square. Because the formula for working out X bar is summation of AX divided by summation of area, and y bar is summation of ay divided by summation of a. The next thing is to find out center of this area, which is C1, but from origin point. The horizontal dimension is 100. Center of this C1 from the origin point in x direction is 50 millimeter. X1 is equal to 50 and y1 is equal to 50 divided by 2. This is 25 and this distance from here to bottom is 200. So I need center of this C1 from the bottom datum axis, from the origin. So it would be 50 divided by 2 plus 200. So y1 is going to be 225. Now you will ask me here that why it's written y2 over here. So in my opinion, this is a typo mistake. So this should be y1. Now what we are doing here is that we are finding the center of first area and that center point, its coordinates from origin. Origin is this point O. And then we have another area, which is this area. This is C2. Now this second area, the horizontal dimension is 50 and vertical dimension is 200. So can I say A2 is equal to 50 into 200? This will be 10,000 millimeters square. Now X2 is horizontal dimension from this point. This is center of this area to vertical datum. All right, this is my X2. So X2 and X1, they are same. This is going to be 50 millimeter and Y2 is distance from this point to bottom. It will be half of 200, which will be 100. So Y2 will be equal to 200 divided by 2, which is 100 millimeter. No matter how much complex a shape is, if you divide it into manageable areas, then you can find out its centroid quite easily. But the key thing is to locate origin and then find out the coordinates of center point of a particular area from that origin. And then the next step is to put these values into the formula for x bar and then y bar. X bar is equal to summation of a into x divided by a, and a into x would be, we have two areas. Can I say a1 x1 plus a2 x2 divided by, we have two areas, a1 plus a2. A1 is and x1 is 50 plus a2 is 10,000, x2 is 50 divided by a1 is 5,000 plus a2 is 10,000. This will give me value of x bar. I'm getting 50 millimeter. Y bar will be equal to summation of ay divided by summation of a. Summation of ay means a1 y1 plus a2 y2 divided by a1 plus a2. A1 is 5,000 and y1 is 225 plus a2 is 10,000 and y2 is 100 divided by, we have 5,000 plus 10,000. What answer are you getting? In my calculator, I am getting 141.67.
Yep, I got the same.
Excellent, Daisy, thank you. Now I have this center point. The coordinates of this center point are 50, 141.67. We found out the centroid of this section and the values are 50 into 141.67. These are x bar and y bar values. Our next job is to find out the second moment of area, I-axis, for this compound shape. We're using this parallel axis theorem to work out I for the compound section. And for compound section, the formula is, it is summation of Ixx plus a y dash minus y whole square. And that is termed as parallel axis theorem. Whatever elements I have in the compound shape, I will work out its second moment of area individually. Remember my words, I have to work out its second moment of area for that particular element, not the entire compound shape. I is equal to bd cube over 12. So b here is 100 and d is 50 over 12, 1.042 to 10 raised 6. This looks fine to me. So for the second one, it will be 50 is width and depth is 200. 200 cube over 12, 33.33 into 10 raised 6. Then I need to find out y bar minus y. Our y bar was this value, 141.67. Y means y1. So distance from center of this shape to the bottom, which is this 225. So 141.67 minus 225 minus 83.3. And for the second one, it would be this value, 141.67, take away 100. So 41.67, this is fine as well. Here, you can say y bar minus y, or you can say y minus y bar. It's one and the same thing, because you know that for the formula, that bracket has square. When it has a square, then it means that even if you have a negative value, you will get the same results. So it doesn't really make much difference if you're saying y minus y bar or y bar minus y. It's one and the same thing. It will lead to the same result. The next thing for us is to find out the a into y minus y bar square. So let's find out if this is fine or not. So area is 5000 times y bar minus y is 3 minus 83.33. If you square it, you will get 34.7194, so or 72. This is fine. So the next one is 10,000 times 41.67 square, which is 17.36 into 10 raised 6. Now all I have to do is to add it up. I am getting 52.083. So this looks fine to me as well. Now using this formula, Ixx for the compound shape, I have summation of Ixx plus a into y minus y bar. All I have to do is to sum up these two values. One is this one and other is this one. So 52 plus 34, it looks like it's 86 something. So this looks fine to me. 86.4583. So this is my Ixx. If I had that value, I can probably find out moment.
Let us now solve example 2, which is a compound section with triangles and rectangles.
This is a compound section, and we have to determine the position of centroid and then calculate the second moment of area about x-axis through the centroid. So now we have this compound section where we have a combination of triangles and rectangles. The key idea is to divide it into number of areas, work out the distance from that area to a particular point. So first area is this one. Now how do we find this horizontal distance? We have this 400 here, we have 400 here, and then we have width of this rectangle is 100. So 400 minus 100 is 300. It is equally shared between two triangles. So 300 divided by 2 is 150. So that's how we find out this dimension. So this is 150. This is 100. And then I'm sure we will have this area as well. So this is again 150. The first area is 150 by 150. How do we work out center of a triangle? Area of the sections, rectangle, width into height. Area of triangle is half base into altitude, and area of circle pi d square over 4. Centroid of triangle is from the vertical side, it is h over 3 or b over 3. The other side, it is 2h over 3 and 2b over 3. Now I forgot to mention one thing is we need to take the origin. This is x and this is y, and this point is O. Center of this area, which is here, is 2b over 3. 2 times b, width is 150. So 2 times 150 divided by 3. 2/3 of 150 is going to be 100. So can I say that x1 is equal to 100? So that's where I get this 100. Say this is my area 1. And how do I get my area A1? So A1 is a triangle. So it would be half base into altitude. Base is 150 and its altitude here is 150 as well. So 150 into 150. It is 11250. Now this is where A1 comes from. So second area is this rectangle, 450 into 100. And the second area is this one. Width of this rectangle is 100. Depth is going to be 300 plus 450. So A2 is going to be 450 times 100. So 45,000. And X and Y. X is going to be half distance. From here to here, I have 150. And from half of that, so this is 50 and this is 150. X2 will be equal to 200 millimeter. Y2 is going to be a distance from this point to bottom. So distance from center of 450. So it would be half of 450 plus 100. Half of 450 will be 225. 225 plus 100. This will be 100. Overall, it will be 325. So Y2 will be 325 millimeter. Now Y1 will be the overall dimension from top to bottom is 550. So I want a distance from this point to the bottom. This is my Y1. And you know that distance from here to here, this is equal to h over 3 using this formula. So h over 3 is going to be 150 divided by 3. It is 50 millimeter from the top. Now tell me what will be Y1. The total distance from bottom to top, 550. Take away 50. So 550 take away 50. Y1 is equal to 500 millimeter. So now we need to consider area 3, which is this one. Now you can see that Y1 for area 1 and Y3, they are same, aren't they? Because vertically, this center will pass through the same point for third area. And the area of this third triangle will be same as the first one. Let us find out X3. So the centroid from 90 degree to this point, this is B over 3. So this horizontal distance is B over 3, which is 150 over 3, which is 50. X3 will be distance from this point to the end point. That is 100 plus 150. Plus 50 will give me X3. The summation of 150, this dimension, plus this dimension, plus this dimension will give me this X3. This will be 300. Now we have these dimensions. We know how did we work out. Now the final one is 200 by 100, which is the bottom part. It's 200 wide and 100 millimeter. This is area 4. Now the center of this area 4, this is Y4. What will be Y4?
50.
50, excellent. We have to find X4. X4 will be the center point to origin, okay? X4. The distance from center of the point to the end is half of 200, which is 100. And then again from this corner to the end, we have this dimension, which is 100. So can I say that X4 is going to be 200? 200 by 100, we just have to multiply. And then X4 is 200, as we saw, and Y4 is 50. Now you could say that, okay, I wanted to divide it in a different way. That is still fine. You can have one trapezoid and then two rectangles. That is still fine. So you can divide it, I mean, in whatever way you like. The resultant X bar and Y bar is still going to be the same. We have to find summation of areas. Let's sum them up. I'm getting 8750 summation of all areas, which is here. And then we have to find out A1 X1, A1 Y1, A2 X2, A2 X2, A2 Y2, and these are here. So A1 X1 11250 multiplied with 500, you will get 5.625 into 10 raised 6. This is a1 y1, a2 x2, and this is a2 y2. This is a3 x3. This is a3 y3, a4 x4, and a4 y4. Now simply add these up. Summation of ax is 17.5. So summation of ay 26.875. Now simply what we have to do is that simply we have to find out summation of ax over a and summation of ay over a. So simply put value of ax, which is, so we just simply have to put these values. So summation of ax is 17.5 10 raised 6 divided by summation of a is 87500. I'm getting 200. Okay, again this is 26.875 into 10 raised 6, and this is 87500, 307.14. Again this is fine as well. X bar and y bar means that now we have found the centroid of the shape, and now we want to find out second moment of area. So the first thing first, we need first of all Ixx for each individual element. Now as you know that I had these 4 elements, what was Ixx for triangular shape? I think it was bh cube over 36. So I'm using this formula, bh cube over 36. So b here is, so it would be 150 into 150 cube over 36. So this will give me 14.0625. So this looks fine to me. If this is fine, this should be fine. Check the second one. So the second value is 100 into 450 cube over 12. I'm getting 759.375 into 10 raised 6. Yeah, so this value is incorrect. The one which is written here is incorrect. And finally check this one, 200 into 100 cube divided by 12. I think the third one is fine. If you add them up, you will get 804.2. Remember that X bar was 200 millimeter and Y bar was 307.14 millimeter. And then we have X bar and Y bar, and Y minus Y bar or Y bar minus Y. Y is 307.14. Sorry, that's Y bar. Y is 500 minus, so 192.86. Remember that Y minus Y bar or Y bar minus Y is one and the same thing. Here I think these values are for Y bar minus Y, and again these values are for Y bar minus Y, but this is one and the same thing. It doesn't make much difference if it is negative or positive. The second one is again 325 minus 307.14. It makes sense, it's 17.86. This is fine. The third one and the first one, they should be the same. And finally 307.14 take away 50 will give me 257.14. Now I have to multiply square of this with the area. Area is this one. So area times this value. So 11250 times.
The first one is correct.
First one is correct. This one. Yeah, first one is correct means third one is correct as well. Okay, go for the next one. 4500 times 17.86 square, 14.35. This is fine as well. And finally go for the last one, which is 20,000 times 257.143 square, 1322.45. This is good as well. If you add them up, this is giving me 2173.68. I think this is fine as well. So what we have done is that we have found out Ixx and we found out a y minus y bar square, and then we came up with these values. Now the main thing is for us to find out the Ixx for the compound section, which is summation of Ixx plus summation of a into y minus y bar or y bar minus y whole square. Now this value was fine, which is related to here. The second value was wrong. So we have to write this 804.8 It's giving me 2977.8, so this is wrong.